Assalamualaikum warahmatullahi wabarakatuh, and hi everybody. Welcome back to Statistical Reasoning in Education. So I'm going to continue explain about analysis of variance or ANOVA. I am Dr. Nur Asniza Ishaq. So the objective of our lecture today, as a continuation from our previous lecture, would be to discuss post hoc tests comparing using multiple comparison. So in One Way ANOVA, I already told you that the process of analysis will run the process of looking at the mean difference of your categories in the independent variable simultaneously. So when your analysis shows a significant value or p is less than 0.05, it indicates that at least 2 out of 3 of your levels or your independent variable is having mean differences. But we do not know which means are different from the groups. So in order for us to do that, we need to run a multiple comparison to look at which group having the mean difference from one another. So it is not possible to do several two-sample t-tests. The probability of type 1 error goes up for each test done. So a procedure that looks for differences between pairs of groups with a global type 1 error rate, example alpha is 0.05, is necessary. So one-way ANOVA using a multiple comparison. What is one-way ANOVA by using a multiple comparison? So it's also known as a post hoc comparison or using a post hoc test. So these are tests to compare the group means in ANOVA. Since the ANOVA test show a significant value, so we need to know which group are different from one another. So all of these tests compare each group mean to all of the other group means, but keep the family-wise error rate below alpha. So when performing a post hoc comparison, it is important to make sure that the family-wise error rate is less than alpha, which is 0.05. So the probability of having at least one type error among the entire set of tests is called the family-wise error rate. One-way ANOVA post hoc tests have so many examples of tests that can be done. Example of the test that you can use for post hoc test would be a Bonferroni test and other post hoc methods which include Scheffé, Tukey, and SNK, which stand for Student Newman Codes. So what is Bonferroni test? Bonferroni test is a method where most of conservative approach will use this Bonferroni test. The one that is less likely to claim that an observed difference is significant. And for your information, all of these methods are less conservative than Bonferroni. And the methods that are less conservative than the Bonferroni are the Scheffé, Tukey, and SNK. However, you can choose any of these methods in order to run a post hoc test. So how do we run a post hoc test analysis by using SPSS? So repeat the step to perform a one-way ANOVA, which means you go to the menu bar, choose Analyze, choose General Linear Model, and then choose Univariate. And then you need to key in all the IV and the DV into the box. And there is a menu of post hoc where you need to choose the post hoc and then move the IV to the post hoc test for box. Check the boxes next to the post hoc test selected. Go to Continue and then click OK. You only run post hoc tests if your ANOVA is significantly different or significantly show there is significantly show that there is a differences of at least 2 groups from your independent variables. If your ANOVA test show that it is not significant, then there is no need for you to run a post hoc analysis. So once again, I'm repeating here that post hoc analysis only be run when your ANOVA test is significant. So how to read an output from a post hoc test in ANOVA? So first, it have a multiple comparison where it reports the difference between every possible pair of factor level and test whether each is significant. And it includes the boundaries for a 95% confidence interval around the size of each difference. And then there is a homogeneous subset, which reports a number of different subsets of the different factor levels. There is a significant difference between the mean of 2 factor levels only if they do not appear in any of the same subset. So when you are reporting a post hoc test, either you report multiple comparison only, or you can also report by having homogeneous subset. Another thing that you should consider by running ANOVA test besides running the post hoc test is to run a graph or to perform a graph of group means in SPSS. So you repeat the same step to perform a one-way ANOVA, but do not press the OK button, but you click the plus button. And then you move the IV to the horizontal axis box, add the IV, you click continue and then click OK. So as what happened after you run the analysis by using SPSS is that you will see an output of a profile plot. So what is a profile plot? Profile plot is a line graph of the group means, which you need to report together with your one-way ANOVA analysis. So it consists of estimated marginal means of your variables. So a profile plot of one factor shows whether the estimated marginal means are increasing or decreasing across level. So the main plot is a visual representation of what we saw in the compare means output. The points on the chart are the average of each group. So this is the point. It shows the average of each group. It's much easier to see from this graph that the current smokers example had the slowest mean sprint time, while the non-smokers had the fastest mean sprint time. So here you can see which group having higher mean and which group having lower mean. For example here, smokers in Southeast have higher means compared to the Northeast and the West. So this is how we read a profile plot. It shows the estimated marginal means of your variables. So thank you very much and hope that you should be able to understand how and when to run a post hoc analysis. Thank you very much.